All right. So, how about MyLabs Plus? Everybody getting on okay?
Yep.
No, I'm not able to log on.
I had to reset my password, and my username wasn't my full email. It was just my first initial and last name. So it took me a while to log in because I had to figure that
Yeah, that's
out.
what I've
Well,
been
thank
typing
you
in.
for telling me that. I thought it was your, no, it's not your, you leave off your at tctc.edu.
And then I still had to reset my password.
Okay. Well, you did that also, and it worked. So maybe that's something you might want to do in case you're running into problems. Reset your password. If your T number doesn't work, then reset your password. Okay? As the handout says, do not put at tctc.edu. That's what the handout says. Okay? Don't do that. Another thing, a lot of my people that buy the computers that don't work half the time, what's they called? Mac users. Okay? You have to download Chrome. Safari doesn't work very well with MyLabs Plus. So, and also remember to turn off your pop-up blockers because they don't work well either. Whatever y'all use on Macs, okay? So, anybody else got any hints? Mac users, anybody got hints?
Mine just works. Yeah.
Well, I'm gonna be honest with you. 90% of the students that I deal with, it works, okay? But 10% could break an apple with a banana, and it takes them 4 weeks to get on to MyLabs Plus. Okay? So I'm just saying, I'm giving you some hints. Has anybody used, I know one person here at AC has used the website, the TCTC website. Is it working for you to get in? Yes or no?
Yeah, it does work.
Well, I would suggest using the website versus what? Blackboard, because Blackboard is going to add insult to injury. If you're already having problems logging on, Blackboard is going to add problems to that.
It's pretty bad because I had a hard time getting into Blackboard just a second ago.
See? And I'll get emails from students. I can't get into Blackboard. This is 3 or 4 weeks into the semester, and I don't reply because I told you not to use Blackboard in the first place. Okay, so, all right. Any other concerns about the class, about MyLabs Plus, anything? Any questions? Okay, well, here we go. Let me turn on my handy-dandy PowerPoint, and we're going to go into number theory. Now, that's a big 25-cent word for can you find the least common multiple in prime numbers. That's what that is. Okay, so we're going to talk about this, and I'm going to be honest with you. I had a person this morning tell me that they didn't know the difference between a prime number and a regular number. And that's nothing to be scared, nothing to be, embarrassed about. A lot of people don't. So I'm going to write a couple of things up here for y'all. And the first one is, what is a prime number? A prime number is a number that is only divisible by itself and what? And 1. Some of you may think it's the odd numbers, but it's not because 2 is enclosed in there, and you can't say just odd numbers, but a majority of them are prime. 1, 2, 3, 5, 7, 11, 13, 17. What's the next one? 19. No sneezing in class. Okay. Now, you can't say they're all odd because 9 is what? 9 is odd, but it's not up there. So what's the opposite of prime numbers?
Composite.
Composite. Some of you fishermen, dang old composite rod, dang old different materials, meaning multiple things in that rod. So composite means divisible by the rest of the numbers. Divisible by other numbers. So whatever numbers are not prime are composite. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. You can't say all even because there's a 9 and a 15 in there. Now, number theory basically is talking about factoring and putting together. That's what number theory is. And what is a 25-cent word for factoring? Breaking it up. Okay? So I'm going to erase this here. Give it about 5 seconds so that way if you're watching the video you can pause it. But these are the numbers we're going to be talking about in the first two sections, or first couple of sections we're going to be going over. Prime numbers, we're not going to be talking about composites that much, but we're going to be thinking in terms of prime numbers. So when I say factor something into prime numbers, I don't want you to use any of these numbers. So let's talk about factoring. Factoring is a 25-cent word. No coughing in class. Factoring is a 25-cent word for expansion. If I asked you, if I spelled that right, if I asked you to factor 54, 99% of you would say, oh, that's 6 times 9. You just have factored 54. Of course, there's one guy that's usually sitting in the back of the room, well, I thought of 2 times 27. Shut up. Okay? Most people think in terms of their multiplication tables, right? If I ask you to factor 21, you're going to say 3 times 7. If I ask you to factor 100, you're going to say 10 times 10. Okay? So most people think in terms of their multiplication tables. But this is what we call factoring. Now that's good, but that's not what we want. Okay? In the first couple of sections of this book, or chapter 5, I don't want you to factor. I want you to prime factor. I want you to factor in terms of prime numbers. So that means I'm going to take 54 and I'm going to put this in yellow so you can bitch and say I can't see it. 6 times 9, and I'm going to think 6 times 9 in my head, and then I'm going to say 2 times 3 times 3 times 3, and that is prime factorization. 2 times 3 to the third power. Now, a lot of you are saying, well, yeah, that's simple. Okay, then why is it so important? I'll tell you why. I have this discussion with my kids all the time. Would everybody agree that mathematics is stair-stepped? Would everybody agree to that statement?
Yes.
Okay, so I'm going to write down the stair steps, but I'm going to write them in terms of things if you don't learn, you'll suck at it. Everybody with me? So here we go. The first thing that you need to learn in mathematics is your tables. Notice I didn't say multiplication tables. I mean tables. Your multiplication table, up to 15. Your additive tables, up to 15. Your subtractive tables, up to 15. And your division tables, up to 15. What do I mean, Hubert? If you count on your fingers, you're going to suck at the rest of the mathematics. If you have to use a calculator to multiply 3 times 6, if you got to use a calculator to divide 27 by 3, if you've got to use a calculator to add 17 and 2, then we got problems. The next thing is prime factorization. The next thing is what we call least common multiple. And here's where it breaks off. Goes into fractions, and then fractions go into algebra, and 2 or 3 concepts of algebra. I'm not going to write them down because we don't need them right now, okay? So why do people suck at algebra? Because they don't know how to add fractions. Why do people suck at adding fractions? Because they don't know how to find the least common multiple. You know why people suck at least common multiple? Because they don't know how to do prime factorization. So that's why in Math 155, we start with the prime factorization. Okay? Now you're talking about clearing fractions in algebra. You're talking about complex rational expressions. You're talking about rational expressions. That's 3 chapters in algebra that people fail because they can't do fractions and least common multiple. So, these two, I think this is 5.1 and this is 5.3. That's what we're going to work on, and then I'll work on 5.2 later. So you need to make a note right now. I'm working on 5.1 today, and the next one will be 5.3. We're going to come back to 5.2 later, at least if this book goes with the book that I'm used to. So, all right, so I'm going to erase this and see what they're going to bring up. Oh, this is that stuff that, you know, they send down to Columbia. Big words, make you feel good about yourself. I'm looking for an example. Lord, Lord, Lord. There we go. Okay, write these down. Now, you can find these on Google. I'm going to write it down on Google. Because I tell students to use Google a lot to pull up cheat sheets. Okay? You want to Google divisibility rules. Or there, I'm sorry. Google that right there. And you can print out and put it on an index card. Rules of divisibility. And they go up to 9. Okay? And there are probably going to be 2 of them. Let me see if there's 2 of them on this one. Yep. So let's just write down, don't write down every single word. Just get a good feel of it. And remember, there's 4 more. So make a box and make 4 more down at the bottom because we're going to do the next one also. So 2. Okay? And the number is even. So it's divisible by 2. If the number is even, it's divisible by 2. If the sum of the numbers add up to be a multiple of 3, then it's divisible by 3. Okay? and so on. So all you need to do is write, and leave 4 spaces down here so you can write down the next 4. Or you can go to Google and Google it and print it and put it on your index card. Probably be a big index card if you want. And if I tell you to put something on the index card, you might want to do that for when you have to test, unless you want to fumble through and look through your notes and waste a lot of time. So your first index card here should be rules of divisibility. When did you add the class?
2 days ago.
Okay, so you should be on the roll. You should be on the roll. It takes 24 hours. And you should be able to get on My Labs Plus
I
now.
got one.
Okay.
Yeah.
I mean, you didn't take you 4 or 5 days? Give you a couple more minutes. Five is easy. If it ends in 5 or 0, it's divisible by 5. 10, if it's got a 0 in it, it's divisible by 10. Now this is going to help you with your prime factorization, because this, hold on a second, we'll use per day. Prime, prime, prime. And the next few are going to be prime, so okay, I'm going to go to the next screen, and don't worry if you don't get it, because all you got to do is Google it. So, and I know that causes, see, you got to Google it, then you got to find the one you like, and then you have to print it out. So I know that's a lot of work, but, I trust that y'all will persevere. Here's the rest of it. And your prime number here, you don't have any prime numbers here. They're all composite. But it kind of helps to know what's divisible by a certain number. Now, some of you should be saying, oh yeah, I remember that back in the 6th, 7th grade. I think I learned it when I was a senior in high school, I think. But anyway, most of you should have learned it way back in grammar school. And I guarantee you there's somebody going, I've never seen it before in my life. Probably not. I don't think you need to write down 10. I think everybody knows that one. But give y'all a couple more minutes. Okay. Now remember, if you don't get all of it, that's fine. Just go back and Google it. I'm going to move on, okay? Next. They're talking about factoring here. I do not use branching, okay? So when you're doing your homework, you're going to see this, and then this. I don't do that. Now, I showed it to you a while ago in branching with the 54, but I don't do that. Now, go ahead and write down your homework. The explanations in your homework is going to be different from the way I show you. But my way is not my way. I didn't come up with it. But the way that I show you is a whole lot better when you're trying to find the least common multiple. So I don't want to teach you two different methods. I'd rather just teach you one. Does everybody understand that? So remember, your homework will be a little bit, it will be explained a little bit different. I would suggest that you just, in 5.1 homework and 5.3 homework, don't use the explanations. Just send me your questions because I don't want you to get mixed up. Did everybody hear that? Oconee, Pendleton, Easley? 5.1 and 5.3 homework. If you have a question, I want you to send it directly to me. I don't want you to do the tree thing because that confuses people. And when you see it in just a minute, you're going to know what I'm talking about. Here we go. 1500. This is a test question. And I tell you when it's a test question or not. Product of what? 2, 3, 5, 7, 11, and sometimes 13. Those are that's your new universe now. Whenever I asked you to find the prime factorization of a number, the first thing you should think of is 2, 3, 5, 7, 11, and sometimes 13. Because when I put a number up here, somebody's going to say, oh, that's 6 times. You just missed the boat. Okay? Those numbers don't exist anymore. In 5.1 and 5.3, the only numbers that exist are those numbers right there. So I'm going to write down 1500 and I'm going to put it in a table. I'm sorry. 1500. Now, using your divisibility rules that you just wrote down, you know this number is divisible by 5. Well, Hubert, why didn't you use 10? 10 don't exist. When you're talking about prime factorization, 10 does not exist. So I can't use 10, I'm going to have to use what? 5. So then you say to yourself, 5 will go into 1500 how many times? And then you think, okay, 5 again. 5 will go into 30 6 times, and then the 0 drops down. Now, if I just did those two problems, 5 will go into 300, and 5 will go into, 1500 and 300. If I did those two problems, and you're going, yeah, that's right, then everything's good. If you're having to go to the side of the paper and do long division, that's not a good sign. And you should not. Well, I've not told anybody to get out a calculator because we haven't got to calculator math, nowhere near. So I don't want to see anybody using a calculator. Because the whole point of this is to be able to do this in your head with fractions with common denominators, not to do it with a calculator. So it ends in 0 again. So that means another 5. 5 will go into 6 one time. That'll leave 1 remainder. 1 0 is 10. Again, you should be able to do that in your head. Now we can't use 5, but what can we use?
3.
3 or?
2.
2. I don't care. Doesn't matter. I'm going to use 3 because you said it first. So I'm going to put a 3 here. That'll be a 4. What goes in 4? 2. That'll leave a 2. And 2. That'll leave a 1. And that 1 tells everybody that what? We are done with this problem. So highlight that 1, and that means you're done. So the prime factorization of 15 is 2 to the second times 3 times 5 to the what? That is a test question, and that's the way you do 5.1. On a 30-question test, you probably have 5 or 6 of these. But I got a question. Now, the question that I always get is, well, Hubert, I could have done that, divided by 10. Not following directions. 10 is not a what? Prime number. And you can't use prime numbers when you're finding the least common multiple. Simple as that. Let's see if I got it right. Now see the way they did it? Now when you're doing least common multiples, it's very difficult to do the tree method with least common multiples. But they got the same answer I did. 2 to the second. Should have a 3 in there. Oh, 3, there it is on the left. 3 times 5 to the third. Or, I ain't going to do that. There's the answer. There we go. That's what you need to write down right there if you need to write down a solution. Now they did it, they didn't get 1. I like to tell students that you want 1 because when you do the least common multiple, you want both or 3 1s on the bottom or 2 1s on the bottom. Just do what I do. Just take it down to 1 and it'll help you out later on. I'm going to go ahead because you already got that written down because we've already done it. Okay, we're going to wait here. Let me go back. We're going to do some more because I'm going to give you 2 or 3 examples because I'm a good teacher and I don't want y'all to succeed. No, I'm just kidding. Let me get, oh, oops. I'm trying to get a white screen. Just bear with me. There we go. All right, I'll mark this out. Let's do another one. Let's do 144. I'm going to give y'all an easy one. So you start off with 2, 3, 5, 7, 11, and sometimes 13. So try that problem, and if you can't do it, consider yourself a failure in life. Or a disappointment. Or maybe you should even quit school. Oh, too much vodka. So, y'all hadn't told me. I already asked the Anderson campus. Pendleton, Oconee, and Easley. How's your first couple of days of school or your first week?
Good. Yes, doing all right.
Oh, come on. You ain't got no weirdos, classmates, or weirdo teachers yet? You don't know yet, or what?
Not that I know of.
Not yet. Not yet.
Okay, well, you'll get them. We used to have a guy, there was a guy expelled. He would pass out cards, and they had, his name was Dr. Love. Buddy, they didn't even counsel him. They just expelled him. He was at the Pendleton campus. Then we had the teacher that, I told y'all about Red Solo Cup teacher, didn't I? Red Solo Cup. I fill you up. Every hour he filled it up. Boy, that's hard and salty if you can drink. Let's see, what does a cup hold? 12 ounces, about 12, 16 ounces?
Oh, it's grown up.
That's 48 ounces by lunchtime.
Okay.
That's hardcore. Ooh. Okay, I'll shut up. You're not going to talk to me, so. I'm doing the problem. So, what am I going to start with? Well, it's even numbers, so I'm going to start with what? 2. 2 will go into 14 7 times. That'll leave a 4. 2 will go into 4 2 times. Is that the way you're supposed to do this? Yes. You should be able to do long division in your head. If you don't, then you need to start practicing. All right? You need to put that 2 will go into 14 7 times. 7 times 2 is 14. That 4 will drop down. 2 times 2 will go into 4 2 times. Now, is 72 even? Yes, Hubert. Thank you for your communication class. 2 will go into 72. 2 will go into 7. How many times? 3 times. That's 6, which will leave 1 remainder. With the 2 is 12. 2 will go into 12 6 times. Keep going. If you haven't yet. If you haven't finished it, keep going. Or you could quit. Quitting's easy. Pink Crocs. Is that butterflies or palm trees?
Palm trees,
Uh,
I think.
I'm partial to butterflies. All right? So how many times will 2 go into 3? 1 time?
Priority 1 message coming in on secured channel. Gmail.
I don't know what that was. Huh. Meeting at 1:20. I'm sorry, that was an alarm for a meeting I have after class. Okay. So how many times will 2 go into 3? 1 time. That leaves the 1 remainder. What's 1 and 6 together? 16. 2 will go into 16. What? How many times will 2 go into 18? 3. And 3. There's our 1. And our prime factorization of 144 is 2 to the 4th power times 3 to the 2nd power.
You have a work email.
Let's do another. Let's do $243. Two, 3, 5, 7, 11, and sometimes 13. I'm sorry. I messed up. 343. My bad. Good God, what's going on? Sound like y'all wrestling somewhere. Good gracious alive. There, 343. Sorry. I'd just go ahead and quit. Dude, that's too difficult, right? I'll have to turn that microphone down. Good gracious. These microphones are very sensitive, so when y'all are doing whatever y'all are doing, it sounds like 10 times louder, so. So, the only number that will go into 343 is 7. How do I know that? Because 7 times 9 is 63, and it ends in a 3. I'm trying to, 3 times 11 is 33, but 3 plus 3 is 6. 6 plus 4 is 10, and the divisibility rule says divisible by 3, it's got to equal what? A multiple of 3. So you can't use 3, you can't use 2, you can't use 5, you can't use 11 because 11 is not going to give you 343. 11 is going to might give you 333. So the only thing left really is 7. And that's why you need to know those divisibility rules. And I guarantee you there's somebody going, I need to learn those divisibility rules. And yes, you do. It's something that a lot of people have either not been taught, or they've been taught and they what? Forgot. Thank you, class. 7 will go into 34 how many times? 4. That's my alarm. I'm organized.
Hi there.
Hi there. It's time for you to shut up. It's time for you to let these people go because they won't leave. 7 will go into 34 how many times? 4 times?
4 times.
4? I'm sorry. I just messed up. Hold on a minute. That dang alarm got me messed up. All right. 7 will go into 34. Yeah, you're right. 4 times. I don't know what I was thinking of. And 4, that'll leave you at 28. What is 28 from 34?
6.
6. And then bring the 3 down at 63. How many times?
9 times.
Yes, 9 times. I've done got this all messed up. Dadgum. I'm sorry. That alarm messed me up. I keep messing myself up. I must be having a stroke or something. 7 will go into 34. 4 times. There. And then 9. There we go. And then 7. How many times will 7 go into 49? 7 times. And then how many times will 7 go into 7? So the prime factorization of 343 is 7 to the what power?
Third.
Now, that's how you do prime factorization. Now, I want you to work on homework problems in 5.1, but I do not want you to work on least common multiple or greatest common divisor. Do not work on those. All I want you to work on is the least common the prime factorization. Everybody with me? So if it's only 5 problems, you just work on those 5 problems. If it's 10 problems, work on those 10 problems. Send me questions if you can't do it. Capiche?